Let's first understand what exactly is a shading mask. I'm standing in a place and viewing buildings around me. Say, I'm going to design a building here. So I'm going to have a permanent view of buildings around. What that means is I cannot see a portion of sky from my current location.
Why do I care about sky view? Because as long as there is access to sky, there will be daylight. Apart from the sun, sky is a source of daylight. So if I see a view like this, the buildings and other structures are masking some portion of the sky. It means that the sun will certainly not be visible from these areas in the sky. For the remaining sky areas, the sun may or may not be visible. Why is that? Because sun is visible in the sky only as per its trajectory. So depending on the sky view from the point of observation, sun could be visible or not be visible. Again, why is it relevant? It is important to know this so that we can identify which areas on the site or the facade or fenestration of the building needs to be shaded or exposed from the sun. To derive meaningful design strategies, we would need such data for the entire year or for several instances in the year. How can we get this data?
One way is to take the model of the site and project shadows at various times of the day over it to see whether these shadows fall across the point of observation at any instance of time. But this can be a tedious process. Instead, how about I create a diagram of the profiles of all the obstructions in the sky as it is visible to me right now. This is the concept of a shading mask. A shading mask is a diagram showing the portion of the sky which is obstructed by objects such as adjacent buildings, natural landforms, and landscape from the observer's eye. Imagine the sky dome as a hemisphere centered at the point of observation. Now, if we project all permanent elements surrounding the point onto this hemisphere, the resulting profile shows the parts of the sky that stay blocked out as viewed from this point.
The sky dome is represented in this diagram. 0 degrees is the horizon and 90 degrees is the zenith. And the profile of the surrounding buildings or objects when projected on the sky diagram looks like this. This is a shading mask. Shadows are created only when there is sun, so you can see shadows only in the daytime, whereas the building which is masking the view to the sky will be there during night as well. It is not creating a shadow, but it is obstructing the view to sky. The obstruction itself can be shade or cast a shadow on another building depending on the time of the day. But the shading mask profile will be the same. Makes sense? A common mistake is to confuse shading mask profiles with shadows. Shading mask is not a shadow.
So, I sometimes like to call this as a sky obstruction diagram instead, which is not as confusing. It is good to keep this at the back of your mind while we continue using the term shading mask. Let me explain this further so you're absolutely clear with the concept.
This is an example of a site which is surrounded by buildings of varying heights. How would the shading mask appear as viewed from the center of this site?
This is the shading mask at the center of the site. The gray parts indicate the portions of the sky that will remain permanently obscured from the site's center. Can you match the buildings to their corresponding profiles on the shading mask? Okay, so let's take a look at the site again and observe the orientation of the buildings. The high-rise building lies somewhere in the southeast direction and the low-rise lies somewhere along the northeast. The blue mid-rise straddles the west while the pink mid-rise is located along the southwest. For our ease, let's label the quadrants in the sky diagram. Now, which building do you think corresponds to the long and the thin profile in the first quadrant? You can see that this profile lies towards the northeast direction. Let's go back to the site view to see which of the buildings lies in the northeast direction. It's the green building, so this profile here belongs to it. The building has an elongated shape as well, so that's why its shading mask profile appears as a long strip.
Can you now identify the shading mask profile for the blue building?
The blue building is to the west of the site, so its profile would also lie in the west. So it's this profile here. Similarly, you can correlate the other buildings to their respective shading mask profiles. How about if you were to move to a new point that's 20 meters away from the center of the site? Would the shading mask change then?
Yes, it would, since the view of the surroundings will change from a new location. Hence, the shading mask profiles would appear different from a new observation point. Shading masks can be generated for any point, be it on the ground, on a building's facade, on a window, or on the rooftop. For just about any surface or location, the principle stays the same. Take for example a point on this window here. This is how a shading mask would appear as viewed from the center of the window. Why do you think the shading mask looks like this, with half of the sky blocked out? It's because when you observe the sky from a vertical surface such as a window, you can view a maximum of half of the sky vertically and maximum of 180 degrees horizontally. It's because beyond these limits you'll be seeing the room and hence the sky won't be visible.
That's why half of the shading mask appears gray in the shading mask profile at this window.
Coming back to the shading mask profile, you now read that half the sky is visible. Another thing to note is that the window is oriented towards the north. That's why the north sky is visible and half of the east and west as well. Now we do not see any building profile here because the window is much higher than the surrounding buildings. I hope that's clear. Always remember, shading masks always give the sky view and not the ground. From the window, I am looking upwards towards the sky and not downwards towards the ground. That's why the surrounding buildings were not visible in the previous example.
Okay, let's do some short exercises to reinforce the concepts. For this facade here, can you tell its orientation from its shading mask? Is it oriented towards the north, south, east, or west? Notice that the southern sky is completely visible on the shading mask. So that means the facade faces that direction. So the facade's orientation is south. Of course, if there were some other buildings or obstructions towards the south of the building we're looking at, then some part of the southern sky might have been obstructed too. Okay, here's another one. The shading mask for the facade here is a bit different from the previous example. How do you think the facade is oriented now? So the profile of the visible sky is not entirely towards the east, nor is it entirely towards the south. It's in the southeast direction. So the facade is oriented towards the southeast. Here is another exercise. So here is a group of buildings around a site. Can you identify the right shading mask for the point shown? You can select any one of the buildings and note its orientation and identify the same on the shading mask. So let me start with the L-shaped building here. It's along the southeast. So that's where its profile should show up on the shading mask. So option C is the right answer. I hope these exercises give you a good hang of the concept.
Now let's move to a window on the ground story of this building. Here is its shading mask profile. You now know why this half of the sky appears grey in the shading mask, but what about the other grey portions? Well, since this window is lower than many of the surrounding features, these features obstruct its view of the sky. Now let's move to the rooftop of this building. Since the building is relatively short, the profile of other buildings is visible. From the roof of this red building, the entire sky is visible because it's the tallest. I hope you're now understanding the concept. Let's now take this understanding further and work with sun path diagrams in the next module.